Chicago Center, this is PLTW 2005, request for landing. Oh, hey, how'd you get here? Oh, you want to know, I'm trying to oh, you want to know about aerospace. Okay, well, let me put the brakes on. Whew. I almost overshot the runway. Trying to land here at O'Hare. So let's talk about aerospace engineering and what we do in this class. Have you ever seen an airplane flying overhead and wondered how it works? I mean, it looks like it's just kind of floating there, barely moving. It still amazes me that something that weighs several 100,000 pounds, because that's how much they weigh, big commercial airliners, that they can fly. It amazes me. And I know how they work. So we learn all about aircraft design and performance, how to calculate aerodynamic forces like the lift and the drag. You might have heard of those. And then we apply those lessons to design, build, and test our own gliders. And then once we know how to design them, we learn some basic navigation techniques and tools, and how to fly airplanes using flight simulators. Well, in fact, that's kind of what you caught me doing at the beginning. But we have a lot of fun. Aerospace vehicles, but that's both aircraft, satellites, spacecraft, they operate in some pretty hostile and harsh conditions. So we take a deeper dive into the design process, where we study all about different structures and materials. For example, have you ever seen an airplane made of wood or steel? Well, there's a reason why, and you'll find out in this class. One of my favorite parts about the course is propulsion. We study everything from propellers and different types of jet engines to what makes a rocket engine work, and we even test a few. We design launch vehicles, which most people call rockets, but we call them launch vehicles, using some pretty cool software, and we put our engines in them and we test them. We do actual launches outside, and these aren't the kits that you buy at the hobby shop. These are things that you design, build, and test.
2, 1.
And that transitions us right into some orbital mechanics and space travel, where we learn about satellite orbit strategies and what it really takes to send a manned mission to Mars. You might hear Elon Musk and other people talk about how easy it is. It's not. It's pretty challenging. One of the things you'll learn is how to design an orbital mission. You get to choose it, and we make an app that lets you track satellites like Hubble Telescope or even the International Space Station. We wrap up the year learning some robotics and how to control remote systems, where we design and build our own version of a Mars rover like Curiosity. It's have sensors and systems to gather a bunch of data, and we operate it remotely. Finally, we learn all about aerospace careers. You might think that aerospace engineers only work on airplanes or rockets, but they work in a lot of different industries. Besides being pilots and working on aircraft, they do things like automotive work. You might find an aerospace engineer working for an Indy race team or a NASCAR team, honing the aerodynamics of their automobiles, or even just a regular automobile maker. They also work in electronics, and they design blades for wind turbines, so they work in alternative energy. One of my personal favorites, though, and I still have a friend in the industry, is astronaut training. So I hope you enjoyed this review of aerospace engineering. Now it's time for me to get back to work. Well, thanks for stopping by. I'm glad I got to share with you what we do in aerospace engineering. Now I have to go finish landing my plane. Chicago Center, I'm back. See ya.